Elizabeth Cochran, a seismologist with the U.S. Geological Survey.
Let's first of all just talk about how earthquakes can generate tsunamis across oceans.
Yeah, so a tsunami is generated when the water is basically forced upwards when an earthquake happens. So if there's a fault that's under the water, and it moves the ground upwards. That then moves the water upwards, and the water then, of course, wants to flow away from that. And so that's what can generate a tsunami. And in the case of very large events, those tsunamis can be large enough to travel all the way across ocean basins.
There's different types of earthquakes. Is there one in particular that makes us more vulnerable to tsunamis?
Yeah, that's a great question. So most of the time we see tsunamis occur with what are called subduction zone earthquakes. So a subduction zone is simply the place where two tectonic plates meet and one plate goes underneath another. The reason that those can be most dangerous is one, they're typically located offshore, the subduction zone areas. And two, because you have one plate scraping underneath another, there's a really large fault that you can have. And the larger the fault, the larger the potential earthquake, and therefore the larger the potential for a tsunami. Finally, it's the direction in which the fault actually moves. So in these particular subduction zones, you're forcing one plate over the other, and when that plate moves up, the water on top of it gets forced upwards and then creates a tsunami.
You mentioned different strengths. Does it really matter? Is there a correlation one-to-one ratio between the strength of the earthquake and the potential tsunami?
There's definitely not a one-to-one correlation between the two. However, they are loosely correlated. So the larger the earthquake, the larger the potential tsunami would be. However, lots of factors come into play. For example, if the earthquake is deep enough, it doesn't break the Earth's surface, so it doesn't have that same effect of forcing the water upwards. So if the earthquake's deep, it may not cause a tsunami. If where we see most of the issues is when the earthquake is shallow enough that it ruptures the Earth's surface. And, again, because you're forcing the ground upwards, then you can generate the tsunami moving outwards. And then there's other factors. So, for example, the size of the tsunami will depend at a given location, will depend on, partly how far away you are from that earthquake. Of course, if you're very close to the earthquake, the tsunami is likely to be much larger. And also your local bathymetry, so what the seafloor looks like offshore as that tsunami wave comes and interacts with the local seafloor, you'll get different size and different height tsunami waves in that location.
Okay, so you've inspired multiple questions from that particular answer. I'll start with the first one is the 8.8. It seemed like it was a fairly deep earthquake, which, if I understood that right, wouldn't necessarily produce a huge tsunami effect, right? The deeper it is.
So this event actually was not terribly deep. The other factor, so it started about 12 miles deep, yeah, under the ground. The other factor is that earthquakes of this size in particular are not happening at a point. So it starts somewhere, and that's what we report typically as its location. We say the location is wherever it started, but then it can rupture across a very large fault area and rupture all the way up to the surface. So this one, in fact, because we have seen a tsunami, we know that it ruptured up to the surface and to form the ground, the surface of the earth, such that it caused a tsunami.
Who's doing the assessment of the earthquake and then the following tsunami effect?
Yeah, so that's actually a great cooperation between USGS and NOAA. And so the Pacific Tsunami Warning Center is under NOAA, and so they are in charge of issuing tsunami watches and advisories like we saw over the last day, particularly for the US here. The USGS our responsibility lies in quickly understanding what the earthquake looks like. So understanding what the depth is, what type of earthquake it is, and then NOAA can take that information and then make the assessment of what the tsunami risk is, and then evaluate what happens, as they get additional readings of what the tsunami height is from sensors out in the ocean.
And in terms of, you've been mentioning tsunami wave, but this is a series of waves that come through, right?
Correct.
So let's talk about the generation of, okay, this is forming as this wave, but then it comes in as a series once it reaches the coast.
Mhm. Yeah, so that's because it's a lot of different factors. First of all, the earthquake takes quite a long time to rupture. So because we have a really long fault, this earthquake took about 200 seconds to fully rupture from where it started to where it ended. And you will get tsunami generated all along that long length of fault. So already you're generating multiple potential sources for the tsunami that then travel outwards. And then, of course, we've got other factors such as, once the tsunami interacts with the local coastline, you can get additional disturbances and sort of reflections of waves off the coast, and that will result in this very extended sequence of waves that can impact our coast for many hours.
Let's talk about this event in particular, the 8.8 that happened just off the east coast of Russia. Uh, that tsunami impact traveled thousands of miles across the Pacific. Uh, how can how forceful that earthquake must have been to be able to have impacts all the way on the U.S. West Coast? How are you assessing all that?
Yeah, so it's with an earthquake of this size, it's affecting a huge amount of area close by in terms of the shaking that occurred. So one of the things that we do is look at what we expect the shaking to be across a wide region. And, additionally, as you mentioned, the tsunami factors, you're looking at kind of what happened during the earthquake and how exactly it ruptured across a region.
Okay. Anything else you wanted to add? Anything that the USGS and NOAA have collaborated since the 2004 Indian Ocean incident, or even in 2011 in Crescent City here in California, we had some pretty destructive tsunami waves. Anything that has kind of been changed or shifted in that collaborative effort?
Yeah, so I think we're always working to improve the information that goes out. In particular, I would say, for folks who are either living in, working in, or visiting the coast, you should be aware of where the tsunami hazards are. And so there's easy ways, you can put in a location and into your search engine and ask what the tsunami hazard is in California. The California Department of Conservation produces very nice maps. And so I would really say a lot of effort has gone into understanding what the potential areas are that could be affected by tsunamis, and ensuring hopefully that folks have the information available to them to understand what their personal risks are during an event such as this one.
Does climate change have anything to do with earthquakes, subsequent tsunamis, with sea level rise and things of that nature?
I would say it's very much a second or third order effect. So, for example, you mentioned sea level rise. That will change the exactly sort of where we might expect the inundation zones to be. If you're increasing the sea level, you're going to add the tsunami on top of that, and that could potentially mean that the inundation zones are somewhat larger. So I would say it's definitely though a sort of second to third order effect.
And in terms of direction, are tsunami waves always going to move in a certain direction, or do they kind of just spread out? Because we saw some near Japan and then through
Mhm.
Hawaii and Alaska and across the US West Coast as well.
Yeah, so the exact direction that the waves travel outwards and kind of, whether or not you see, depending on where you are, you might see the sea level increase with the tsunami and then decrease as you get different waves coming through. In other cases, you can see the ocean actually drawing away from the beaches prior to the main wave hitting. So that all depends on actually what the fault orientation is and the local seafloor topography or bathymetry where that earthquake source is. And so it has a lot to do with kind of the orientation that the fault is relative to where you are. But in this case, it did affect the entire Pacific Basin.
Yeah, yeah. Well, I'm assuming you all have very good mapping of some of the seafloor and understanding how
Mhm.
that's going to move through because you assess this so quickly. We were getting those alerts almost instantaneously from the point of that earthquake. Is that kind of all hands on deck, get there, figure things out?
Yeah, in part, some of this has been, we've lived through these types of events in the past. We've refined, the information that we have and the expectations for what the tsunami might be in different areas. We also know that there are certain areas that are prone to large effects during tsunamis, such as you mentioned, Crescent City in California. That's an area that's just because of the local bathymetry, kind of what the seafloor looks like there, and the shape of the coastline, we know that area has the potential for greater effects. And so it's, really combining all of this information to then be able to issue hopefully more specific information as time goes on and we collect information about that tsunami wave or the tsunami as it's moving outwards.
Fantastic. Well, I certainly learned a lot of oceanography, geography, or geology, and things of that nature. Is there anything else that you want to pass along to folks that maybe in that zone or visiting?
Yeah, I think the key here, so in this case, the earthquake happened very far away, so we had many hours on the west coast of the US to understand what the hazards might be. I think what I want to drive home is, we're not going to have hours if the earthquake happens right offshore or right offshore where you are. So typically, you want to be aware if you're near the coast, you feel strong shaking. We have this saying strong and long. So if it's a lot of shaking for a long time, that's likely a large earthquake. And at that point, you want to take action and move away from the coast, move inland. Don't wait for information or a specific warning because you may only have minutes to kind of evacuate out of the most risky areas.
Is there anything just off the California coastline or the US West coastline that you're looking at for that's feeling a little more vulnerable right now?
I wouldn't say right now specifically, but the in the Pacific Northwest, we have a subduction zone. We have a very large subduction zone that's capable of a magnitude 9 earthquake. And so that magnitude 9 earthquake, when it happens, will generate a large tsunami along the west coast of the US. And so that's something that we've known about for years. And the last magnitude 9 earthquake in that area, so this is Washington State, Oregon, and Northern California, happened in 1700. We know the date of that earthquake because there was a tsunami generated that impacted Japan. And they had excellent records of what was called an orphan tsunami because there was no earthquake associated with the tsunami, and then it was linked back to this event in the Pacific Northwest.
And
So
did you say that was in 1790?
1700.
1700. Was
Yeah,
that the Cascadia?
correct.
That was
Yes.
Cascadia.
Yes.
Okay. Wow, very
Yeah.
interesting. Okay, so these have been documented for centuries then.
Yes. Yes. So
Okay.
I mean, we didn't make the connection
Right.
until more recently. But yes, we know that there's a pretty significant risk of a large earthquake and associated tsunami nearby.